Along the way, this happened. Yep, the program crashed, and after this, it crashed 2 more times. What's up everybody, it's Izzo. Welcome to the lab and welcome to Devlog 13, the second installment of the Expulsion of Lag Series 2. In the previous devlog, we knocked off the first point on our bug list, which was the buildings and reducing their footprint on the object count. If you haven't checked that out yet, go ahead and tune in so you're all caught up on what's going on in the lab. So, let's get into it. We're on number 2 of the list. Number 2. My bad, I'm a kid at heart. Anyways, I'm really excited for today's project. We're cracking Codename Allnight wide open today and getting into a little bit of how the world is designed and held together, with some light level editing sprinkled in. This devlog is definitely going to go down as one of my favorites. So, number 2 on the list are the segment settings. Let's cut to some devlog 11 footage. Alright guys, so bad news. There is not a single gun console that spawned out of 193 chunks. Yeah, so the first travesty is no gun building. I couldn't even mod my weapons for you guys in the 5-day playthrough. That's actually not important and also intended though, I'm just being dramatic. The chunk count is really what started ringing bells in my head. Almost 200 chunks. That's ridiculous, well at least from a performance perspective. There's a lot that can potentially be going on in just one chunk, so 200 of that is way too much. So that brings us to the mission for today. We're decreasing the maximum amount of chunks in one segment, and the result should be less objects, which is less calculations, which is less lag. So, let's get it. Alright, the first thing we have to do is decrease the maximum length of a segment. That's done with these two values, current max world width and default max world width. The default value usually controls the segment width, but there is a case where the environments may try to generate at the end of a segment. In that case, no environment generates and a value called fixed max world width is set to the current world width plus a chunk size, which is 480 pixels. Okay, now that we're all caught up, me included, let's take a look at this. Currently, the max world width is 480,000 pixels, which is 1,000 chunks. That's way too much. So we're gonna shorten it to 48,000 pixels, or 100 chunks, which is substantially shorter, but should greatly decrease the amount of objects possible in a given segment. Now, this is one of the rare times in the lab we don't need to test this. The mechanics I just went over can handle those changes, to those values without introducing new problems, which honestly, I'm grateful for. I'm not trying to run off 100 times to see if this works. So I guess we're done for today. That's it for today's experiments. Thanks everyone. Nah, I'm just kidding. Really though, I hope you didn't move to the next video. We're in a test game and I'm gonna run off the screen a few times. However, I modified the max world width to only 6,400 pixels. I gotta show you guys something very important, so let's run off and generate a new segment. And here we are. The important thing I gotta show you is right here. It's nothing. Yep, nothing. No buildings, no trees, no rocks, nothing. Let me explain. The start of every segment, including the first segment, has 4 chunks generated at the start. I call it the start area, and it's used to really allow me, the developer, to give the players some type of start to the game. For the first segment, it's always the same library building, starting crates, and an assortment of trees and rocks. For every other new segment, it's nothing. For now, that is. That's the second part to our mission today. We're going to populate these starting chunks for newly generated segments. Alright, here are the 2 main focuses for now. First up is this group of events. It's responsible for toggling the world generated flag. It tells the system the world is generated and it's safe to start doing calculations and whatnot. It's also the gatekeeper to spawning the player in. We don't need to go over everything, but overall this first event is our main focus, and we'll be working with the global string called GameState. It tells our system which way to handle segment generation, either a new segment or loading in an already saved segment. The other focus is this event responsible for generating the start area in the first segment. The goal here is to create a variant of this event to generate start areas for new segments, using the same flags and the same properties. I'm not really keen on making a whole new set of logic and properties for this, so let's get started. The first problem is game state is altered too early. We need to check it to make variants of the start area generation, similar to how the world calculates how to generate. We want to check that string, and based on it, we'll either generate the first segment start area or the new segment start area. What we need to do is make this event wait for the start area to be generated. This flag will do the trick. It's called start area generated. Now we can start implementing. Alright, we got a solid start. We added in the check of start area generated, so now we can use that game state string. And in the actual generation logic, we're now turning on that start area generated flag, so that the world generation flag can still be turned on. We also have an event to turn off the generation active flag. This is a precaution just in case we want to use that flag or this logic again. We just turn that flag back on and boop, it executes this logic again. Magic. Okay, you know how we do in the lab after changing something. We gotta do that honorary test. The test is simple. We're just gonna start a new game and make sure everything generates still. Everything looks good, we get that full start area generated in, and as an extra check, we're looking into an object using the built-in debugger. We're looking at the start area generated flag and the start area generation active flag. The former needs to be true, which looks good. The latter needs to be false, which also looks good. All changes work perfectly. I love it when that happens. So we're on to the next. Alright, time to take this to the next level. We're converting this event into a fast loop. We're going to use a couple non-changing values, also known as constants. The program doesn't have support for constant properties, so I just prefix values with const. These are going to be used for loop control. Instead of using literal values, we're using values that we can change once and not have to change multiple places in the code. So let's get started. Alright, let's go over this. Our starting point is that first event responsible for world generation. We stuck a loop in there to generate the start area. It's going to replace the flags we're using now. We're using that constant value we set up earlier to set the number of loops. Then down in the actual start area generation logic, everything happens in 2 iterations. The first iteration spawns in all objects, while the second iteration turns on that start area generated flag, signaling everything went okay and allowing that world flag to be turned on so gameplay can start. With all of this, we're ready for another test to make sure the conversion went right. We have the same test conditions as last time, just making sure that start area generates in successfully. Everything's looking great, we're ready to move on. Alright everyone, it's time to design some new possibilities for chunks to generate. Literally, we're level editing. In the past, I usually did this all on paper and translated it straight to events. But this is the lab and it would be pretty hard to get that on camera. So I'm putting together a little level editor program to assist us. It'd be lovely if I could talk today. Here's what we're working with. We got the tree and the rock objects for some scenery and early material getting. And we got some buildings. I only took the ones that are allowed to generate outside of environments. That's just to keep on theme with the world that's being established. So, the design plan. It's simple. We're going to be plotting all these objects around these 4 chunks. Then we're going to code in all the possibilities. All 4 chunks will have the possibility to either generate a set of trees or a set of rocks. And then the even chunks will be used for spawning in buildings. So now that we got that plan going, let's start designing. Alright, we got the first part done, a full scene of trees. We got the pattern alternating from 3 to 4 to 3 and finally another 4. Now that we got some type of terrain going, it's time to start experimenting with the building placements. We're going to use the biggest building first so that way we can kind of get a general positioning for all the buildings. For our options, that happens to be the infusion building. So let's get back to designing. Alright, we got a good starting point for placing buildings. We stuck to our design plan and got them plotted on the second and the fourth chunks, the even ones. The placement creates this sort of enclosed space between the buildings, kinda like they're part of a community or something. A little consequence of the buildings being put is that we had to rearrange the trees around it. It's fine, we'll just have to take that into consideration when implementing this design. Anyways, now that we got a good general layout for the buildings, it's time to place the other buildings, and I have to record their positions for implementing it into the actual logic. So, let's get started. Alright, I hope you guys enjoyed that time lapse. We got all the buildings placed and coordinates recorded for implementation purposes. We got one more stop, and that's placing the rock objects. So, let's get to it. Alright, that was a lot, but we got it done. What's going on is I plotted both variants of all chunks generating rocks. There's one variant for no buildings included in chunks 2 and 4, and one for buildings generating on chunks 2 and 4. All that's left now is to make these objects' existence a reality. Along the way, this happened. Yep, the program crashed, and after this, it crashed 2 more times. Just lovely, and I didn't save it, so yeah, I had to restart 3 times in total. I think the maths? Anyways, after that, I just stopped recording and knocked out the logic. It was getting late, and it's pretty much all the same thing as the start area generation logic. However, there are some things that I do want to point out with the start area generation logic and some changes. First off, there's 5 new properties that are used to assist with randomizing things. We got a material randomizer, which will randomize the material type, either trees or rocks, for each of the 4 chunks. We got 2 properties that handle deciding if there's a building included in chunks 2 and 4. They can either have a value of 0 or 1. Then we have 2 properties that have the code for which buildings should generate. It can have a value of 0 to 4. Basically, it has 5 options, so for each of the 5 buildings. All these values are set within the event that starts the start area generation. We use a function called random, which generates a random number between 0 and the argument you provided. Then we mod whatever value comes out of it. Mod is short for modulus, a common operator for coders and game programmers. It divides its operands and gives the remainder instead of the quotient. So when used with 2, it gives you values from 0 to 1. When used with 5, it gives you values from 0 to 4. Therefore, we can basically make sure that all of our properties are randomly being set, and its random is a little bit higher than what we could do just by using random values of like 2 or 5. Alright, that's enough talk. It's time for the test on the start area generation. We're keeping those same test world dimensions of 6,400 pixels, still not trying to run off 100 chunks, so yeah. The goal here is to generate in a new segment and make sure we got some generation on those first 4 chunks, and make sure all logic for extending the world still works. Well, would you look at that? It worked. First try. We went to a new segment and it generated terrain randomly. Then expanding the world still works too. I'd say this has been another successful day in the lab, guys. Alright everyone, it's been a busy one today in the lab, but we got 2 victories. 1, we got another task scratched off the bug list. 2, we implemented something new without errors. That one right there is crazy, at least in my experience. But anyways, that's enough babbling for now. Thanks everyone for joining me in the lab today. Leave a like if you enjoyed today's lab project, let me know what you think in the comments, and subscribe to join me in the lab for more experiments. Alright guys, have a good one. See you for the next one.